Hello! Welcome to another video of detailed math solutions. In this video, I'm going to show how to expand binomials with monomials of a higher degree, third degree, fourth degree, fifth, sixth, and so on. First, I will go over some key math concepts that are needed to solve these exercises, and then I will write and explain in detail the solution for each exercise. To expand each binomial, I'm going to apply the formula a plus b in parentheses squared equals to a squared plus 2ab plus b squared. I'm also going to use the rules of exponents for power of a power and power of products with 2, 3, and 4 factors. When I need to apply the rule for power of a power, I will multiply the exponent n and m. To find the power of products with 2, 3, and 4 factors, I will distribute the exponent to each factor of the product. Next, I'm going to show how this is done for each exercise. Exercise 22a. Expand the binomial x cubed plus z to the fourth power in parentheses squared. This binomial has two terms. The first term is x cubed. The second is z to the fourth power. X cubed corresponds to the a in our formula, and z cubed corresponds to the b in our formula. Therefore, when we apply the formula, this equals to x cubed in parentheses square, or the first term squared, plus 2 times first term second term, 2 times x cubed z to the fourth power, plus z to the fourth power in parentheses squared. As a next step, I'm going to use the rule for power of a power and multiply the exponents 3 and 2. Then x equals to x to the sixth power. Then rewrite the second term because we can't simplify it further. This equals to 2x cubed z to the fourth power plus z to the eighth power. Next exercise. Expand the binomial a to the fourth power plus b to the fifth c in parentheses squared. This equals to a to the fourth power in parentheses squared plus 2 times a to the fourth power b to the fifth c plus b to the fifth power c in parentheses squared. We simplify the first term further. This equals to a to the eighth power, plus then we rewrite the second term to a to the fourth power b to the fifth c, plus then we need to use the formula for power of a product of two factors, ab to the power of n, this formula right here that I just underlined, and distribute the exponent. So this equals to b to the fifth power in parentheses squared c squared. And then what is left is to simplify just the third term. And then we rewrite the first two terms because we can't simplify them further. This is the final form for them. And then the third term is b to the fifth power in parentheses squared. We multiply the exponents. This equals to b to the 10th c squared. We can simplify further, so this is our expanded form of the binomial for this exercise. Next exercise. Expand the binomial 3x to the fifth power multiplied by y plus 7z cubed in parentheses squared. This equals to the first term squared, 3x to the fifth y in parentheses squared, plus 2 times 3x to the fifth y multiplied by 7z cubed, plus second term squared, which is 7z cubed in parentheses squared. If we distribute the exponent 2 for each factor of this product, this equals to 3 squared x to the fifth in parentheses squared y squared, plus the middle term we have numerical parts 2, 3, and 7. We need to multiply those first and write them down. So this is 2 times 3 times 7 is 42. And then the factors that are left are x to the fifth y z cubed, plus then we have 7 squared z cubed in parentheses squared. If we simplify further, we get 9 x to the 10th y squared, plus we just rewrite the middle term because we can't simplify it further. It equals to 42 x to the fifth y z cubed, plus 49 z to the power of 6. Next exercise. Expand the binomial 6ab cubed plus 5c to the fourth power d in parentheses squared. This equals to 6ab cubed in parentheses squared plus 2 times first term 6ab cubed in parentheses multiplied by second term 5c cubed d plus 5c cubed d in parentheses squared. Again, we need to distribute the exponent 2 to each factor of the first term. This equals to 6 cubed a squared, 6 squared a squared b cubed in parentheses squared, plus then we need to multiply numerical parts again. 12 times 5 is 60. A, B cubed, C to the fourth, D are the remaining factors of this term, plus 5 squared, C to the fourth power in parentheses squared, D squared. What's left is to simplify the first and the last term of this expression. So this equals to 36a squared b to the sixth power plus 60a b3c 4d, we just rewrite this term, plus we have 25c to the eighth power d squared. Next exercise. Expand the binomial 8m to the fourth power n squared plus p cubed q in parentheses squared. And again, we apply the formula for binomial square, and for the first term, we get 8m to the fourth power n squared in parentheses squared plus 2 times the same term, m to the fourth n squared multiplied by the second term p cubed q plus second term squared. Again, we need to distribute the exponent. We get 8 squared m to the fourth power squared n squared, again squared, plus we have 2 times 8 to make 16 m to the 4th power n squared p cubed q. Plus then we have p cubed to the power of 2 and q squared. Therefore, this equals to 64 m to the 8th power n to the 4th power plus 16 m to the 4th n squared p cubed q plus p to the 6th power q to the 2nd power. Next exercise. Expand the binomial 2s squared t cubed plus 4u to the 4th power v to the 5th power in parentheses squared. This equals to 2s2 t to the 3rd power squared plus 2 times 2s squared t to the 3rd power multiplied by 4u to the 4th v to the 5th power plus 4u to the 4th power v to the 5th power, and then this squared. We distribute the exponent 2 squared s squared squared t cubed squared plus, then we have 4 times 4, 16 s squared t cubed u to the 4th power v to the 5th power plus 4 squared u to the 4th squared v to the 5th squared. Simplifying further, we get 4s to the 4th t to the 6th plus 16 s squared t cubed v to the 4th, u to the 4th v to the 5th plus 16 u to the 8th v to the 10th power. Next exercise. Expand the binomial 9a to the 5th power, b to the 3rd power, c squared plus x to the 4th, y to the 6th, z to the 7th in parentheses squared. This equals to 9a to the 5th b cubed c squared plus 2 times 9a to the 5th b cubed c squared multiplied by x to the 4th, y to the 6th, z to the 7th in parentheses plus x to the 4th, y to the 6th, z to the 7th power in parentheses squared. This equals to 9 squared a to the 5th to the 2nd power, b to the 3rd to the 2nd power, c squared to the 2nd plus 18 a to the 5th b cubed c squared x to the 4th y to the 6th z to the 7th plus x to the 8th power, y to the 12th power, and z to the 14th power. I distributed the exponent, directly multiplied, and I got the exponents. Then what's left is simplify our first term, which is 81, a to the 10th, b to the 6th, c to the 4th, plus 18. We just need to rewrite the rest of the expression. a to the 5th b cubed, c squared, x to the 4th, y to the 6th, z to the 7th, plus x to the 8th power, y to the 12th, z to the 14th power. And then we have one last exercise to complete. 3m to the 4th n squared p cubed plus 6q to the 8th r to the s power, r to the 6th power, s to the 5th power, in parentheses squared. This equals to, again we apply our formula, distribute the exponents, follow absolutely the same steps that we followed so far. Okay, so this equals to 3m to the 4th n squared p cubed squared plus 2 times 3m to the 4th n squared p cubed, in parentheses multiply by 6q to the 8th r to the 6th s to the 5th power plus 6q to the 8th r to the 6th s to the 5th, in parentheses squared. And I'm going to apply the exponent to each term and calculate it and write it down immediately, so there is not that much writing. Okay, so 3 squared is 9m to the power 4 to the squared is 8. Then we have n to the 4th power p to the 6th plus 2 times 3 times 6 is 36, and then the factors that are left are m to the 4th power, n to the 2nd, p to the 3rd power, then q to the 8th, r to the 6th, s to the 5th power, plus we have 6 squared, 36, q to the 16th power, r to the 12th power, s to the 10th power. And this concludes our exercises. Thank you so much for watching and learning. If you like this video, please click the thumbs up and subscribe to the channel for more exciting videos.